Hello everyone, my name is Leo Rivera. I'm the Director of Scientific Outreach here at Meter Group. And in our previous videos, we've talked about some of the sedimentation approaches for measuring particle size analysis. Today, we're going to talk about our optical approaches for measuring particle size analysis of soils. And the three most common methods for making these measurements are X-ray attenuation, laser light scattering or laser diffraction, and Vis-NIR, visible near infrared spectroscopy. Today we're primarily just going to focus on the laser diffraction method, but X-ray attenuation and Vis-NIR spectroscopy are also both very good tools for measuring soil particle size distribution optically. The way the laser diffraction method works is we're basing it on the fact that particles that are different sizes diffract light at a different angle relative to that size. And so light is passed through a suspension of soil, and again, we need to disperse and treat that soil just like we would for the sedimentation methods. But that light is passed through that suspension of soil. You can see an example of that sample cell and the light being passed through the sample and the receiver. And the diffraction of that light is measured with those detectors. And then we use the Mie theory to relate that diffraction to the different particle sizes that are in suspension. The typical sizes that we can measure with the laser diffraction method are 0.04 to 2000 microns. So not quite down to your clay sizes, but it gets pretty close. But that is kind of one of the limitations with the laser diffraction method. Some other challenges with the laser diffraction method is you typically are using smaller sample sizes. So because of that, it can be less representative of the measurement that we're trying to make. Ideally, more sample helps us characterize things a little bit better. It is also very expensive. So that can be a challenge because most of these devices are orders of magnitude more expensive than the other methods that we've talked about. But what's really nice about this method is that you can have a much higher throughput of your samples through this approach, and you're not having to wait for multiple hours to make your measurements. It is a very, very quick measurement. And so that is an advantage if you have the budget and you have the time to invest in a tool like this. It is really nice for that purpose because you can get through a lot more samples. One of the other challenges with the optical method, especially with the laser diffraction method, again, like we talked about, we're measuring the diffraction based on the particle size. And clay particles, for example, are flat. And so depending on the orientation of that particle, you may actually wind up measuring a different particle size than the actual average size of that particle and how it relates to everything else. And so particle orientation can result in error in your measurement. We've talked about quite a few different methods for measuring soil particle size distribution. And we've talked about their pros and cons behind each method. I personally have a lot of experience myself, of course, with the hydrometer method and now the ISP Plus method. But it's really important to weigh the pros and cons that we talked about with your measurement goals and your research goals when it comes to choosing the right tool for making your measurements. And in our next video, we're going to talk about the ins and outs of the PARIO method and the ISP Plus method and how to best utilize those tools for your research.